Welcome to your next module. So in this module, we're going to look at earthquakes. So it's kind of like a continuation of the previous module, although in the previous module we did talk about folds. Here we're going to continue kind of with the faulting stuff. So when an earthquake occurs, we usually get faulting. That doesn't always show up at the surface, but we know that it's a break in the rock, and sometimes we can see that in the rock record, which you were trying to identify as a specific type of fault. So here we're going to learn about what specifically is an earthquake, how does that occur. And so I've kind of broken down the PowerPoint that you have here into a couple different versions or parts, I guess. So the first part is basically just talking about kind of the nuts and bolts of earthquakes. What is specifically an earthquake? How do we figure out its epicenter? What about its magnitude? How do we measure that? So we kind of go through those ideas and explain how we do those things. And then the second part is going to focus a little on some of the hazards that are associated with that. So of course, we know when there's earthquakes, we get falling debris and buildings collapsing, and that's a big hazard. But there's some other hazards that we can see associated with earthquakes, depending on where you live and some other factors. But we can get, landslides and fires and something called liquefaction and things like that. So we want to discuss that. And that's what you're going to do, or that's what the second part of the video is going to discuss. It's all included in the initial PowerPoint here. This third video is just an explanation of how we can get long ground shaking from earthquakes. Because when we talk about earthquakes, there's a rupture, boom, the rock breaks, it releases energy, moves out, causes the ground to shake, and the ground shakes. But in some cases, it shakes for, 15 seconds, maybe 30. Other cases, 5 minutes. So how do we get that? So I'm trying to explain to you how that may happen. And it is related to plate tectonics, but it's just a short little clip of this animation, so you can go ahead and watch that. Hopefully that'll help you understand how that can occur. And of course, a few other videos just to help you understand earthquakes. This first one is from the 2011 Japanese earthquake that occurred. It was really large. And it's just a collection of some video taken during the earthquake. So if you've never been in an earthquake, this is probably the best you're going to get if you ever want to experience one. So if you kind of watch it from about 1:15 to the 7:15, you can see this collection and get maybe an idea of what it might be like in an earthquake. And then this other one is describing a hazard associated with some earthquakes. It's just a little weird, I guess, when you describe it. It's called soil liquefaction. And so it's a great demonstration, and it's also pretty short, just like 3 minutes long. And it just illustrates you how you can get soil to turn to a liquid. And so that's what that video is for. But like I said, the information that you're going to need for the quiz is just in these first two PowerPoint videos and the PowerPoint itself. And then for the article, I'm going to have you look at the largest earthquake ever recorded, so you can just read through that article, learn a little information about that, and then take the quiz. And then for the homework, it's got two parts to it. There's a video that I'd like you to watch, so there's a link in the assignment to the video. It's basically about the 1964 Alaskan earthquake. It's one of the first times that plate tectonics and earthquakes were kind of connected. So it'll ask you a few questions about that specific video, which is fairly short. And then the second part is just some general questions about earthquakes, ones that I didn't ask you in the main kind of part here up in the main lecture quiz, right? So you can use any resources, of course, to figure that out. There's some information always in the additional resources page that you can look through. And then you do have a lab, as always, and here we're going to do a plate tectonics lab. So it's not a specific earthquake lab, but it is a plate tectonics. And I know we've learned about plate tectonics, but of course, plate tectonics is one of the biggest drivers of earthquakes. And so I think there's a connection there. So you can just go ahead and work your way through the lab. And the lab, as always, is set up just like all the other labs. You just work your way through, right? Picking the answers, redo it if you so choose. You need to get a 70%, all that kind of good stuff. Okay, so that's what's happening this week in your geology class. So as always, if you have any questions, comments, or need some help, please don't hesitate to contact me.